Can you tell how many sheep are on the screen without counting them? Difficult? Now, what about this? Much easier, isn't it? Our brains are remarkably good at recognizing small quantities instantly, no counting required. But once the number grows beyond a certain point, that ability disappears. So let's travel back about 10,000 years. Imagine you're a shepherd. You own hundreds of sheep. Every morning, you lead them out to graze. Every evening, they return. But here's the problem. How do you know every single sheep has made it home? Easy, you might say. Just count them. One, two, three. Except there's a problem. Your language has words only for one and two. Nothing beyond that. So how would you say three? Think about it. Perhaps two and one. And four? Maybe two and two. Without number words, keeping track of a large flock would be almost impossible. So how could our shepherd solve this problem? He doesn't need number words. He simply needs a way to make sure every sheep is accounted for. Suppose I own one sheep. I carve one mark on a bone. Two sheep, two marks. Three sheep, three marks. Each time I get another sheep, I carve one more mark. Notice what's happening. I still don't know the actual number of sheep I own, but I do know something just as important. Every sheep has a matching mark on the bone. This simple idea is called one-to-one correspondence, or more simply, one-to-one matching. Every sheep matches one mark, and every mark matches one sheep. Now evening arrives. One by one, the sheep return home. As each sheep enters the pen, I move my finger across one mark, one sheep, one mark, another sheep, another mark. If every mark has been crossed out, then every sheep is safely home. But if even one mark remains, then one sheep is still missing. Notice something fascinating. I'm not actually counting the sheep. I'm simply matching them. Long before people invented numbers, they had already discovered one of the most powerful ideas in mathematics. And this was only the beginning. That simple idea worked remarkably well. At first, people carved marks on bones. But before long, they discovered a much more convenient counting tool: their own hands. Think back to when you first learned to count. You probably said 1, 2, 3, without pointing to anything at all. To us, numbers are ideas. They can exist on their own. But that wasn't always true. Thousands of years ago, people didn't count 1, 2, 3. Instead, they counted 1 sheep, 2 sheep, 3 sheep, or 1 tree, 2 trees, 3 trees. A number was never separate from the object it described. It wasn't an idea by itself. Then, something remarkable happened. People began thinking about numbers themselves, not just the things they counted. That was one of the greatest turning points in the history of mathematics. Numbers had become abstract ideas. But finger counting had its limits. What if your flock kept growing? 100 sheep, 200 sheep, 500 sheep. You only have 10 fingers. So how do you keep track of so many? Here's a clever idea. Instead of thinking about every sheep individually, let's put them into groups. Since we have 10 fingers, let each group contain 10 sheep. Then, whenever we collect 10 groups of 10, we combine them into one even larger group. Suddenly, the problem becomes much simpler. Instead of remembering hundreds of individual sheep, we only need to know three things. How many large groups do we have? How many groups of 10? And how many sheep are left over? With just those three pieces of information, we can work out the total number of sheep. This simple idea of grouping by tens eventually evolved into the base 10 number system we use today. But here's something interesting. People around the world didn't all solve this problem the same way. They all faced the same challenge, but they found different solutions. Many cultures counted with the 10 fingers on their hands. Some counted with both their fingers and their toes, giving them a base of 20. Others developed entirely different number systems to suit their own needs. The destination was the same, only the paths were different. As the centuries passed, villages grew into towns. Towns became cities. trade flourished. People were no longer counting just sheep. They were counting sacks of grain, jars of oil, herds of cattle, and goods arriving from distant lands. Now a new problem appeared. How do you keep accurate business records? You can't rely on memory forever. Sooner or later, you'll forget. People needed a way to record quantities so anyone could verify them. One of the earliest solutions was surprisingly clever. They used small objects made of clay. These were called clay tokens. Each token represented a particular quantity. Let's see how they worked. Imagine you're a merchant. A shipment has just arrived, 415 sacks of rice. How would you record that? Let's invent a simple system. Suppose this small cone represents 1, this cylinder represents 10, and this ball represents 100. To record 415, you simply collect 4 balls, 1 cylinder, and 5 cones. Place them inside a small clay pouch, and your record is complete. Anyone who understood the system could open the pouch and immediately know the quantity it represented. It was a clever solution. But success created a new problem. As trade expanded, merchants had to carry more and more clay tokens. The more business they did, the more tokens they needed. Keeping track of them became difficult. Carrying them from place to place became inconvenient. People needed a better way. So, over time, they stopped relying only on the tokens themselves. Instead, they began making marks on clay tablets. That was an important turning point in the history of mathematics. For the first time, a quantity no longer needed a physical object to represent it. A written symbol was enough. Once numbers became symbols, they became much easier to record, to preserve, to share, and to use in calculations. One of the earliest civilizations to develop such a symbolic number system was the Babylonians. But they made an unusual choice. Instead of counting in tens, they counted in 60s. Why 60? The truth is, we don't really know. Historians have proposed several different explanations, but none has been proven. So, after thousands of years, we still don't know for certain why the Babylonians chose base 60. Even so, their number system proved remarkably successful. Thousands of years have passed, yet traces of it are still all around us. An hour has 60 minutes, a minute has 60 seconds, and a circle has 360 degrees. Every time you check the time or measure an angle, you're using an idea that began nearly 4,000 years ago. Let's look back at the journey we've taken. We began with a shepherd, trying to solve a simple problem. How could he tell whether every sheep had returned home? The first solution was one-to-one matching. Then people discovered they could count with their fingers. As numbers grew larger, they began grouping them into tens. That simple idea eventually evolved into the base 10 number system we use today. As trade expanded, people needed a reliable way to keep records, so they invented clay tokens. Later, those physical tokens gave way to written symbols. Step by step, our modern number system began to take shape. But this is only the beginning of the story. People around the world didn't all write numbers in the same way. Different civilizations developed remarkably different number systems. In the next video, we'll explore some of those ancient systems and discover why some of them were far more powerful than others. But before you go, here's a challenge. We use our 10 fingers to count in tens. But did you know you can count all the way to 12 using just one hand? Can you figure out how? Think you've solved it? Tell us your answer in the comments below. If you're not sure, take your best guess. I'll see you in the next video.